This example goes through finding z-scores or using z-scores to determine women's heights. The example states, assume the heights of women are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5 inches. This is based on data from the National Health Survey. I don't remember the year that I got this data, but it's been a while, so I'm wondering if the data has changed a little bit. But for purposes of this example, we'll roll with it. Part A says, suppose a woman is 5'8". What's the z-score that corresponds to her height? What does it mean? Part B, a friend of mine is 5'2". What's her z-score and how does she compare? And Part C, if a woman has a z-score of 3.5, how tall is she? Okay, so let's get rolling. Let's look at Part A. So I'll go blue here for Part A. And if she's 5'8", our mean is in inches. So we've got to convert that to inches. And so 63.6 inches would be 63.6. Or sorry, if she's 5'8", she is 68 inches. Remember that the z-score formula is your data point minus the mean over the sample standard deviation. So if we wanted to find her z-score at 5'8", that's 68 inches, we're going to subtract the mean, 63.6, and divide by the standard deviation. And that is going to give us, if you do that math, 1.76. I'm going to scooch this down a little bit. And so I just made a bell curve here. And when you're doing z-scores, the mean has a z-score of 0. A z-score of 0 because the mean minus the mean is 0. This person at 5'8" has a z-score of 1.76. What that's telling you is that this female is 1.6 standard deviations greater than the mean. What we consider, and we'll look at that in a second, because I don't think my writing will go with it. We stated that anything within 2 standard deviations of the mean, or a z-score of 2 or negative 2, is considered normal or usual. So 1.76 is taller than the average female, but it's not unusual because it's under 2. So let's look at Part B. Just looking at this friend of mine who's 5'2", I know that she's 62 inches, and that's shorter than the mean. So I know for a fact I'm going to get a negative number here, because 62 minus 63.6 is going to give me a negative number. Her z-score is negative 0.64. That's going to be here. Her z-score is below the mean with a z-score of negative 0.64. Negative because it's smaller than the mean. Still, pretty usual. And for Part C, here we're given a z-score of 3.5. 3.5 is here. Immediately, it's a positive number, and it's 3.5 standard deviations greater than the mean. It's greater than 2 standard deviations. This woman's going to be tall. These are the things that I want you to be thinking about in your head before you even do the math, so that if your math is wonky and you get a shorter value than the mean, you know that you did some calculation wrong, because you know in your head a z-score of 3.5 is unusual and it's larger than the mean. So we've got to work this formula backwards. We've got 3.5 as a z-score. We don't know x. That's how tall she is. We do know the mean, and we do know the sample standard deviation. And what you'll find here when you solve for x is she is 72.35 inches, which is tall. 6 foot, it's about 6'2", which for a female is tall. Okay, let's see what happens to my My writing's going to stay. Okay, so bear with me, guys. If we go here and look at this diagram, which I've shown you in previous videos, this shows basically what I'm talking about here. So we had a z-score of 1.76, we had 3.5, and we had negative 0.64. You'll see between 1 and negative 1, or 1 and within one standard deviation of the mean, 68% of all of your data, if it follows a normal distribution, should be contained within there. Within 2 standard deviations of the mean, or z-score of 2 and negative 2, you've got 95% of all of your data. So 95% of all of your data should be within 2 standard deviations of the mean. So our female who is 5'8" falls within that, and our female that is 5'2" falls in there. Now, the third example, part C, we ended up with a z-score of 3.5. You'll see that female is not within 95% of the observations. In fact, within 3 standard deviations of the mean, you've got 99.7% of all observations. She doesn't even fit in there. She is within 0.3% of females is where a woman that is 6'2" is located. It's pretty cool.